Welcome back to international trade. New tariffs from the United States, and what else will happen? We will see. So, international trade is maybe right now in our days one of the most important topics that you know how this function, and we are just in the explanations, in the theoretical explanation of how we want to explain the international trade dependencies, and we want to dive into the so-called classical theory of international trade. The first one was the Ricardo model, and now we have relaxed the assumption here that we have only one production factor, and since in a classical interpretation, we have to assume that we have constant returns to scale. The reason for this was that this is compatible with zero profits in optimum, and zero profits in optimum is with in the dependence of full competitive markets. So this is the theoretical part behind of our modeling. But now we have relaxed this assumption that in general we will find not only labor as a production factor, but that we have other production factors, and we are now dividing our production function, our inputs, into two general production factors, in general labor and capital, or here, and this is the name then, to specific production factors. One is specific only for one sector, for one good. We can use it only there. Think of the huge tractors in agricultural sector. Well, it's hard to use these machines in other sectors, or think of specific machinery in the industrial production, that it won't be that easy to switch such a machine to another sector. Well, this is also in comparison what you have talked into in your other courses when you distinguished between short-run cost functions and long-run cost functions. So compare this with long-run and short-run cost functions. Why do I say this? What is the difference between long-run and short-run cost functions? Costs are just depending on inputs. I think you have talked about this in many of your introductory courses. And please do not be surprised that the lectures depend on each other. I cannot always explain everything from the starting point. Cost function, how does it look like in general when you are modeling costs? Hi. In general, you are dividing costs into two parts. Hmm? Costs of x equals what? What two? What are the two general parts of a cost function? Yep, fixed and variable costs. So, and now what is the difference between the short-term view with respect to these two parts and the long-run view with respect to these two parts? You have definitely talked about this in general business administration courses, in microeconomics, in investment and finance, and so on. Definitely, because I'm talking to my colleagues. That's a pity. I know what they are doing. When you are moving from a short run perspective, looking at the costs of your firm to a long run perspective. In the short run, you say you have fixed costs. Why do you have fixed costs? Well, you make some long-term investment in some new machinery or something else, and then it is you have invested for 10 million in a huge machine in the chemical sector or something like this. And then you say, well, for the next 5, 10 years, I have this huge machinery, and there is no possibility to just move this machinery away or to sell it. But in the long run, you make the assumption, well, then especially I can sell these investment goods. Then I got the capital, and with this new liquid capital, I can do another investment. So in the long run, no fixed cost anymore because you can sell your things. You can fire your people. Hiring people is also fixed costs because it is not that easy due to your contracts to fire just in a week some guy. Therefore, you have to pay every month. But in the long run, of course, you can lay off your workers. So, and this is then a part of our specific factor model because why? What are the costs here? Here, when we say labor is our flexible factor, capital is our specific factor, then costs equals wages times labor, flexible, plus interest rate times capital. But here I introduce a bar, which means when I have invested in this capital, then I have it. I can use it only in my sector. So this is my fixed cost And since this is flexible, this labor, these are my variable costs. And so we have to say this specific factor model is in general a model for the short or medium term, not for the long run. Then specific factors model is short or medium term model. And please give me the feedback that you have talked about this change of the perspective between, or I know that you have heard of. Sorry. Okay, anyway. So now we have two goods, two countries, and two production factors. And now we have to specify our production function depending now on capital and labor. And there we assume this neoclassical production function. And this production function exhibits two assumptions, positive but decreasing marginal products. What does it mean? Of course, if I increase my input, then I increase my output, but the additional output of every new input unit will be smaller than before. So here, maybe from 1 to 2, increasing, hiring another guy means this additional output, delta y1. And then this right-banded character means the slope is decreasing. And let's say here from 10 to 11, also increasing by 1 unit, means still my output is increasing, but the increase is less than when I come from a lower production niveau. Okay? No, it is still increasing. The additional increase is decreasing. There you have to be careful what means this word of decreasing. This does not mean that your output is decreasing by increasing your input factor, but the additional output. Well, and there, if we talk then technically about it, this means that the first derivative with respect to our production function is of course positive, but the additional output, this is decreasing, and therefore we have to have the second derivative of our production with respect to our input factor is negative. So the second derivative of our function is the first derivative of the first derivative of the function. And a monotonically decreasing function has to have a negative first derivative. Well, and constants return to scale. This again means doubling input means doubling output. Doubling input means in this case, when we have two production factors, now not only doubling L, but also in parallel doubling K. So this means that F of 2 times L, 2 times K means this is double output 2 times F of KL, or in general F of lambda L lambda K equals lambda F of KL. Just the number lambda, any number. Then we can also put an exponent of 1 at our variable, and therefore we call this also F is a function, or is a homogeneous function of degree 1. This is this exponent here, because we could also create other functions which have there, if you taking out this variable out of the function, then there would be a 2 or a 3 or 1.5 or something else. So this, please keep in mind. This assumption means optimal profits equal 0. This means fully competitive markets. And right now we are not using this assumption at many parts in our model. This is, so to speak, only to motivate our model that we are talking about fully competitive markets. But we will, in the next step, then also flexibilize the second production factor. And when we then do the calculations, then we quite often this property of homogeneous degree of 1. So please keep this in mind. In maybe 1 or 2 weeks, we will use this property. Okay, so this is in general our production function. And now what we want to do is compare with Ricardo and the transformation curve where we have had our two goods, B and A, and there we said, well, we have in general a dependence, since we have only one production factor. If we increase labor producing A, then we have to decrease the output of B, and this was just the linear dependence. So increasing the production of A means decreasing the production of B. And what we now want to derive, we will do this now graphically. What is with this new assumption? Two production factors. One is flexible, labor, and exhibiting the neoclassical production function, positive, but decreasing marginal products. How does now our transformation curve look like? And this we will in a minute have then here in the left and the right upper quadrant. There we want to derive the dependence. How much do I have to decrease grain when I'm increasing machinery by 1 unit. Well, how do these two goods are depending on each other? Well, they have their specific capital. There is no dependence because land we can only use in the agricultural sector and the specific machinery we can only use in the industrial sector. So from this part, the production is independent, but they depend via the labor market because we have assumed that the workers can just choose between the two sectors. And therefore, on the down left quadrant, you see here, I'm writing down the labor amount of the industrial sector, and to the left, the labor amount of the agricultural sector. And what we have assumed is that we have a total labor amount in our country given by L bar. So let's say in Germany, these are our 45 million people which have an age between 15 and 65, and this is our labor amount. And these people can choose if they want to work in the agricultural or in the industrial sector. Well, how does now the distribution between these two sectors look like? Well, it is possible that everybody is working in the industrial sector. Then we have this full employment in the industrial sector, and the maximum employment would be this L bar here. This we don't need. This is from sometimes else. Or, of course, we could have the same situation that everybody is working in the agricultural sector. Also L bar. These are two possibilities. Which we choose in the end, we do not know right now. But what is also possible that some people are working in the industrial sector and the other L bar minus this amount of people is working in the other sector. How does it look like in our graphical representation? This is just the linear line with a slope of -1. All points on the line represent different possibilities of the division of L bar between the two sectors, line with slope -1. So, and what we do now is, and some of you have already participated in my macro course, think there about the end of my lecture. There we had also this graphical representation of the neoclassical view of a country, and there we also have introduced the neoclassical production function, and now we are doing just the same, because here we have to the right our output and downward the input of labor, and what we have assumed is this right bending production function. So what does this mean? We just take this diagram and move it 90 degrees to the right. Okay? Then, of course, our production function looks like this. And we are doing the same thing with the agricultural sector. Now we need that upward going is the output, but now to the left is the input. Graphically compared to this diagram, what does it mean? We are just mirroring this functional form with respect to the vertical axis. Okay, just flipping this curve to the right. So this one looks somehow like this. Then let's do it like this. Zap. Better. Okay. So let's do the next one in red maybe. So what we are doing now is we want to draw every combination now of the output products G and M. And of course, we just can start with what would be the output in the situation when everybody is working in the industrial sector. So the maximum output of the industrial good, of the machinery, is just moving here to the right to the production function and then moving upward to the output. So this would be the maximum output which we can produce in our land, giving the resource restriction of a labor amount of L bar. Of course, the same we can do for the situation if the total labor amount is situated in the agricultural sector, then we are moving up there to the production function, and going to the right means now this would be, oh sorry, not G max, M max, of course. So, and now what's the interesting part? How do these possible output combinations look like in between? And this is now a difference to the Ricardo model. Since we now have not any more linear production functions, but these right-banded, positive, but decreasing marginal product, neoclassical production functions, it is not a linear line anymore. How does it look like? Well, let's take maybe 80% of L bar still working in the industrial sector. 80% roughly would be then here. Moving up here, this would be then the amount here. But if these people here are working in the industrial sector, we are going to our labor market dependence between the two sectors. Then this means these people here are working in the agricultural sector, 20%. And now moving with these 20% people up on the production factor, we are coming here to the right. This would be the corresponding output in the agricultural sector. And so the intersection of these vertical and horizontal line would be then our output combination given 80%. Let's say this is 0.L L bar, and this would be then 0.2 L bar, given 80% of the people are working in the agricultural, 80% in the industrial sector and 20% in the agricultural sector. Well, let's take also another point. Let's say here, this would be maybe or a little bit more to the right. Let's say this one, roughly 0.6 L bar. Then moving up would be here 0.4 L bar. What would be the output combination? 60% of the people working in the agricultural sector, 40% in the industrial sector. Again, the same construction going up to the agricultural production function. We are just here and going to the industrial production function, ending up here. Then we are here, and then we follow this vertical and horizontal line again and moving up, and we will end up around here. So of course, this construction we have to do for every point lying on this line. Well, I will end up here with these 2 points because the general shape of our transformation curve we see already. And we can also explain it because think of here, starting from here, reducing by 20% means I'm starting from a very high production level. High production level, the other way around here, means reducing by 1 unit means I reduce my output level less compared to an increase from 1 to 2. So what does it mean in our graphical representation with respect to these two products? Means the reduction here has to be less than the increase starting just the production in the agricultural sector. So starting the production means then that you really increase with the first units of input your production level by a very large amount. Means that this part here, as we see it, has of course to be much larger than this part, and the other way around. Here the reduction coming from 100% to 60% has again to be smaller than the increase from 0 to 40%. Well, and this again means that we have also this concave shape of our transformation curve. This would be the linear line, but since to this asymmetrical decrease versus a higher increase, we are moving outward our shape of the production function, and oops, no, this is not good, that we oh, here we are. We obtain also this concave shape of the transformation curve and compare this again with our Ricardo model when we aggregated the two countries, B and A, starting with these two production possibility frontiers. Adding these two up has meant moving this, moving the flatter one outward and then adding up the steeper one on the right side. Also, here we have a concave shape of transformation curve. And this is what we generally assume about these transformation curves, that they are concave. Oops, see. And here we have two different explanations for this shape. Yep. Only when you are here starting from the right. When we are starting from the other position, then it is just the other way around. So what we had here in the Ricardo model, good question or good, very good hint, is in the Ricardo model, the exchange relation was always constant. We always had, I think, three coconuts versus two fish. There, because it was a linear line, it was constant, and here the exchange relation is changing, because the exchange relation, and this we will then in the further analysis, we will need this, that we start in absolute numbers with a flat slope, and then this slope becomes steeper and steeper and steeper, and this is just the exchange ratio between these two goods given some production point. Okay. So now we have our shape of the transformation curve we have to use later on. Keep this in mind. So next one. In general, we want to look at the labor market. And looking at this labor market means that we also want to have the dependence of the, oh, this always has to be an M, sorry. And here also marginal product. The dependence of the marginal product on the input factor itself. And since we are focusing on the flexible factor, the marginal product of labor depending on labor. And here we just use the assumption of our neoclassical production function. The first derivative of the production function is just the marginal product. The marginal product derived with respect to L, positive but decreasing, means we have to have a falling function in the input factor. So, and this we find here just in the representation that you remember it. This is just the first derivative of f with respect to L. Well, what can we now learn from this? We now learn from this that the relation between our two marginal products just equals the slope of our production function. So this is the slope of the production function, not of the production, of the transformation curve. Oh, I just put it down here. Then I do not have to write it down. This is the slope of the transformation curve. And just have a look here. Well, this just means when I'm going down here, this is delta G and this is delta M, and the relation of these two amounts is just the slope of our curve. So how can we derive this? Well, for this we have to do some math. What do we have? We have in general that G, output in the agricultural sector, is a function of the labor input in the agricultural sector. And then we can ask, how does the output changes when I'm changing the input? This means the change of the output is the first derivative of our production function. So G with respect to labor times the change of labor input. So this is change of output, change of input, and this is the marginal product of labor. Well, this we can do also for the other sector. We have also M is depending on the flexible production factor, LM. Then we have the change of output is the marginal product of labor in this sector now times the change of labor input in this sector. But since labor is totally flexible, we have a dependence between these two. But we also know that total amount of labor is just the sum of the two labor inputs. And then just formally, of course, we know if 20 people changing from one sector to the other, the reduction of one sector is the increase of the other sectors. So the change of the total labor amount, this we have assumed to be fixed since L bar is constant, has to be zero. So to speak, the first derivative of a constant is just zero, is just the sum of the two changes. So dlg plus dlm, and then of course we obtain the trivial dependence that dlm is minus dlg. And this we now put in to our two former equations. So then we obtain dg equals marginal product dg dl dlg, and now inserting this down here means dm dl equals dm dl times now minus dlg. We have just inserted this into this equation. And what we are now doing is we are dividing both equations, taking the relation of the left equals the relation of the right side. So dg over dm equals dg over dl over dm with respect to dl times dlg over minus dlg. What a surprise! Here, therefore, for this we have done this interchange. This cancels out, and we only have this minus sign here, and we end up with dg over dm equals minus dg dl over dm dl, and this we call our marginal products of labor in the agricultural sector and marginal product of labor in the machinery sector, which we have here. We know again the first derivative of our production function is positive. So this is a positive number, this is a positive number with a minus sign in front of this. This has to be a negative number. So this is what we want to have. Of course, here this is a downward sloping function. So the derivative of this function, dg over dm, has to be negative. This we now, what we have derived here graphically, this we have now formally derived from the mathematics and the assumptions about our neoclassical production function. Well, hopefully you look at this and then you say, something like this I have already seen before. Where do you have seen something like this before? Let's make an exchange of some letters. Let's say, what do we have? G is x2, M is x1, and MPL is, how did you call it? I think MU, marginal utility. Yep. Not to the utility function, but what did you what have you done when you have calculated your household optimum? You were interested in two things. In the slope of the budget line, which was the price ratio, and in the slope of your indifference curve. This was called, what was the slope of the indifference curve called? MRS, marginal rate of substitution. And the marginal rate of substitution was, what's about the internet? Yeah, of what? No, we are not now in the production view. We are here now in your microeconomics course. What was the marginal rate of substitutions, the slope of the indifference curve, not in the optimum, but in general? Then afterwards you said, well, the budget line has a slope P1 over P2, and now I have to equate this with the general calculation of the slope of the indifference curve. And the slope of the indifference curve was the ratio of the marginal rates of utility with respect to x1 and to x2. So this was du with respect to f1 and the minus sign du to x2. And this is marginal utility. Well, very surprising, or here that the slope of our transformation curve, the dependence between G and M, is conceptually the same as the dependence of the slope of the indifference curve, which shows the dependence of x1, x2. What is the definition of an indifference curve? Yep, this is then the economic interpretation of it. But what do I need for the definition of an indifference curve? Is the dependence between x and 2 given? There I make always the Lothar Matthäus argument. It has to be possible to wake you up in the night at 4 o'clock asking, you want to shoot a penalty? So I have to wake you up and give me the definition of an indifference curve. Every basket, every amount of x1 and x2 given. No, not optimal. We are not in the optimum now. We are just at the definition of an indifference curve. Given constant utility. every point representing many different baskets. 11 apples, 1 liter milk, 6 apples, 4 liter milk have all the same utility. Well, what is the same which we have here? All possible product combinations given what is constant in behind in our production process? The labor, yes, great. Given the total amount of labor. This one. This is constant in behind. So this is conceptually totally the same as you have done it in your micro course. Only that you in your micro course you had a convex shape and now we have a concave shape. Okay, half an hour left. So this we need in a minute, and now we want to derive what is now given the prices of our two goods. We are in fully competitive markets. Remember, in a fully competitive market, I cannot do anything about the prices. I just have to take prices. So now we are assuming that in our society we have the prices due to fully competitive markets. So we take prices as given due to fully competitive markets. PG and PM. So here again, this I forgot to change, M and M, M and M. Oops. So what we do now is we are putting the production situation of our two sectors within one graphic. Let's start, so to speak, with our picture which we have here. And let's assume we are here. What do I have here in the agricultural sector? So we know this is the shape of our dependence between marginal product of labor and input of labor. So if we multiply this marginal product of labor with a constant, this means, since prices are given, we do not change anything of the shape of our function. Every point of this curve here is just multiplied with a constant number. So then we can just draw this would be the so-called value of marginal product of labor. PG times MPLG. So now we say we can increase input only until the total amount of labor we have. So here we have to stop. There are not more people in our country. But on the other hand, we know if we employ in the agricultural sector only this amount, then the rest is working in the other sector. So what we can say now is that to the left, we can draw just the amount of labor in the industrial sector. What does this mean for the representation in via the marginal product? Again, we have just to mirror this function on the vertical axis. So our marginal product now multiplied by the price also doesn't change the general shape, means that our marginal product function looks maybe like this. This is PM times MPLG. And this would be now the intersection of both. This would be our labor market equilibrium. This would be the optimal labor input in the industrial sector, and this would be the optimal labor input in the agricultural sector. L star G and LM star optimal labor input in the two sectors. Well, because why do we have the intersection? The value of the marginal product has to coincide with what given profit maximization? What is profit maximization? What is profit? What is profit in general? I really hope that you know what profit is in general, and this we want to apply. How do you calculate profits in your company? Product times prices is not profit. What is it? Product amount, quantity times prices is revenue minus costs, of course. So here we have, let's take the profit in the agricultural sector is the price in the agricultural sector times the amount we have produced minus our costs. In the beginning of the lecture, we have talked a lot about costs. What is the price? I need it now. So times the wages in the agricultural sector times the labor input in the agricultural sector, and of course also our capital costs, And what do we do if we want to optimize this? Well, this is our specific factor. So this is a constant. G is depending on the flexible factor. So profits are in general depending on the labor input. What are we doing when we want to optimize profits? What are we doing then? Hmm? I really hope I'm not the only one talking about this. Optimizing profits. Well, at least everything in economics is always about optimization processes. What do we do? Taking the first derivative and setting to zero. What is our flexible variable? This is our labor amount. P prime of LG equals, what is the derivative of revenue? We have assumed prices are given, so PG is only a constant for us, times the output with respect to labor input. So we obtain PG times the derivative of output with respect to LG minus what is the first derivative of the costs. Again, fully competitive markets, prices are given, so we have to take wages and interest rates as given. Since this is all given, this is a constant. The derivative of a constant is zero. Okay, we don't have to care about the capital part. What is with the labor part? A constant times the variable. F of x equals 3 times x. What is f prime? 3. F of Lg is Vw times Lg. What is f prime? You can say my 3 is my W and my X is my Lg. Then just W, of course, is wages. What is the condition to be in an optimum for the first derivative? I said to you, please have a look in your microeconomics, in your mathematical introductory course. I just announced this. When we are flexibilizing the second input factor, capital, there will be much more of mathematics we are doing here. And without this mathematics, you cannot understand the model. Everything else would be only just storytelling. And this is not what academic studies are about. Storytelling, this you could do somewhere else. F of x equals x squared. How does it look like? It's a parabola looking like this. The minimum, optimum. What's the characteristic of the slope in the minimum? It's a horizontal line. The slope of a horizontal line is 0. So this we have to set to 0 in optimum. Then what we see, this is our marginal product. So we have PG times marginal product of labor in the agricultural sector equals wages. So what I have drawn here more or less is nothing else than the labor demand function. So these two are labor demand functions. Actually, I have done this with you in my macro course, and I really, really hope that I'm not the only guy here talking about demand and supply functions. So, and for this, then we of course know in optimum, this has to be wages, and this has to be the wage in the machinery sector and the wage in the agricultural sector. So WG, since labor is totally flexible, what has then to be the case with the two wages in the two sectors? We had made the same argument in the Ricardo model. Think of yourself. You have the possibility, due to your abilities, to work in both sectors. In one sector, you obtain 25 euros per hour. In the other sector, you obtain 30 euros per hour. Where do you work? Of course, and in equilibrium, what does this mean for the wages in the two sectors? Since the other sector, which is paying less, of course, wants to be attractive for the workers. Yeah, but what happens then in the equilibrium process? Yeah, at first it shifts. So, but since in equilibrium we would pay different wages, could this be an equilibrium? We just argued if one sector is paying more than the other, then I'm moving there. So there won't be an equilibrium. So wages in both sectors have to coincide. Since labor is totally flexible, we must have W star is the same as the wages in our two sectors. Well, we have drawn our labor demand function and then we see it graphically. The only possibility where we have the situation that we have same wages is the intersection of our two demand function. So this is the other way around. No, here we have G and M. So, and now we are almost done. Since we have this condition here, the optimization process is in both sectors the same. We also have that the value of the marginal product in our industrial sector equals wages in the industrial sector. So PM, marginal product of LM equals wages in the industrial sector, taking this, this, and this together. What do we obtain? 1, 2, and 3 together. We have value of marginal product in the industrial sector equals value of marginal product in the agricultural sector dividing by PG and dividing by MPLM means the relative price equals marginal product of the other way around, G over marginal product in the industrial sector. Where have we already seen the relation of the marginal product? Well, we have derived here the relation as the slope of our transformation curve. So we obtain that this is dm over dg. Oops. And from where do you know this relation also? Price ratio equals the slope of some other function in your household optimum. Compare this with the household optimum. There you had just x2, x1, budget line, indifference curve, optimum P1 over P2 is dux1 over dux2, and I need only also this minus sign here. exactly the same. Price ratio is the relation between the marginal products. Price ratio equals the relation of the marginal utilities. So, okay, what does this have to do with trade? For this, but I think, oops, or yeah, I think, should we already start? No, I think this will be too complicated. Let's do this then. Given, so to speak, now the situation of autarky, I'm alone. This is my market equilibrium. And now we ask what happens in this situation when we are opening for the world market. Opening for the world market means, and here we assume that we are small compared to the world market, also assume the country is small compared to the world market. This then also means we cannot change world market prices. So this means we have to take world market prices as given. And now, and for this you can already think of for the next week, we just assume that at the world market, the price of industrial goods is higher than in our country when we are producing only for us alone. We start here from our labor market equilibrium and then just think of what happens to our curves here. Is there something changing? And then what happens, so to speak, if we do find a new equilibrium? So PM is going up. Okay, that much for today. And next week we will then analyze this model in general.